Mechanics. Is there anyone who can give the definition of mechanics? Anyone from the class?
It is a branch of physics that deals with objects in motion and rest is one.
Good. The branch of physics which deals with the study of objects at rest or in motion is called as the mechanics. From that definition itself, you can say that there are two branches of mechanics. One is statics, other one is dynamics. Okay? What is meant by statics? What is meant by statics? What is meant by statics?
So which is constant.
The branch of physics which deals with the objects at rest is called as the statics. And the branch of physics which deals with the objects in motion is called as the dynamics. And here again, dynamics is of two types. One is two branches you are having. One is kinematics. Keep quiet. One is kinematics. Other is proper dynamics. Maintain the silence. Proper dynamics. The kinematics is the branch of physics which deals with the study of objects in motion without taking the causes of motion into consideration. Without taking causes of motion into consideration, if you are studying motion, then that is called as the kinematics. Without taking the causes of motion into consideration, if you are studying the objects in motion, then that is called as the kinematics. Then proper dynamics means by taking causes of motion into consideration, you are studying the objects in motion, then that is called as the proper dynamics. Okay, in your 9th class also you had gone through the many equations like V equals to U plus AT, S equals to UT plus half AT square, and V square minus U square equals to 2AS. All these equations, whenever you are deriving, you are not asked the question why that acceleration is taking place. And so you had not taken the causes of motion into consideration, and you had derived the equations of motion, or you had studied the motion. So that is why that will come under the kinematics. And similarly, in your 11th syllabus, motion in one dimension, and that is motion in a straight line, and the second one, motion in a plane, that is 4th chapter, both will come under the kinematics only. But if you go through laws of motion, that is 5th chapter, there you are going to study that why the acceleration takes place, and for the acceleration certain force is required. All these things you will study. The causes of motion you are going to take into consideration. So those all will come under the proper dynamics. Okay. Now, before going to the motion, you must know about the point object. What is meant by point objects? What is meant by point objects? So if the distance covered by the object is very high in comparison to the size of the object, then that is called as the point object. If the size of the object is very less in comparison to the distance covered, then that object is said to be a point object. Even a train is also a point object if it is moving from Delhi to Hyderabad. 3,000 kilometers is there, but that distance 200 meters is negligible, so you can take that object as a point object. Suppose if a mug is passing, falling from a table, that means 75 centimeters height is there. Mug is of 30 centimeters, so you can't neglect that mug. Even that mug is also not a point object, but the train is a point object if you are taking the distance is concerned, very large is concerned. And after that, one more thing you must know, that is the motion and rest. Is there anyone who can define motion? What is meant by motion?
Change in the position of the object in respect to its environment.
Very good, very good. That's surroundings. What must be required? With respect to the surroundings, if the object changes its position, then that object is said to be in motion. And with respect to the surroundings, if the object is not going to change its position, then that object is said to be at rest. So object, that motion and rest both are relative. Motion and rest both are relative. You can get it understand from this animation. You just go through it. Now just A frame. You just click. If you are going through with respect to A frame is concerned, that ball and observer B are moving towards him, left of him. Towards left of him, that both ball and observer B are moving. Okay? But if you go through B reference frame, if you click on B reference frame, even though that observer A is at rest, but he appears to be moving towards right. This is the example for motion and rest. Both are relative. So the same ball is at rest with respect to observer B, and the same ball is in motion with respect to observer A. So motion and rest both are relative. Motion and rest both are relative. Not only motion but position also. Suppose if I am observing, see here, if this chair, if you are taking this chair is concerned, for me in which direction it is? Towards left. But if I am standing and if I am coming over here and observing, the same chair is in the right side of me. So that is why position is also relative. So motion, rest, these all are relative terms. You can't say that without taking the surroundings or giving the relativeness, you can't explain either object is at rest or in motion is concerned. So that is why the same thing, that is, you can observe it there, even though actually observer B and ball are moving, but with respect to observer B, that ball is at rest and that observer A is moving towards left of him. These all things you can get it understand. And also even in your daily life also, if you are sitting in a bus and if you are observing the trees, those trees are moving towards backwards of you. Even though you are moving with the bus, but that is at rest. Because if you are seeing the same thing, if you are observing the driver sitting inside the bus, the driver will be at rest. But the same driver, if you are observing from the some other person is observing from the platform, the same driver is in motion. So motion is relative. Note down. What is meant by motion? If the object changes its position with respect to surroundings, then that object is said to be in motion. And if the object does not change its position with respect to surroundings, then that object is said to be at rest. Okay, noted? Next. Based on direction, the motion you can divide it into three types. That is one-dimensional motion, two-dimensional motion, and three-dimensional motion. One D motion, 2D motion, and 3D motion. So what is meant by one-dimensional motion?
Motion in a straight line.
Motion in a straight line, you can take it as the example for one-dimensional motion, and only if one coordinate is enough to explain the motion, then that is called as the 1D motion. If two coordinates are required to explain the motion, otherwise if two coordinates are changing with the time, then that is called as the 2D motion, and if all the three coordinates are changing, then that is called as the three-dimensional motion. Example, suppose if the train is moving in straight tracks, then that is the example for one-dimensional motion. The carom board coin moving in the plane of the board, two-dimensional motion. If you are striking the coin with the striker that is restricted to move in the plane of the board, then that is called as the 2D motion. That is the example for the 2D motion, motion in plane. And similarly, suppose if a bird is flying in the sky, then that is the example for three-dimensional motion. If a bird is flying in the sky, all the three coordinates are going to change, x, y and z. Then that is taken to be as the 3D motion. Okay, note down. One dimensional motion. It is that motion in which only one of the coordinates. It is that motion in which only one of the coordinates, either x or y or z, one of the coordinates changes with respect to surroundings and time. Changes with respect to surroundings and time. Is called 1D motion. So only one coordinate changing out of x, y and z. And example, train moving in a straight tracks. Train moving in the straight tracks. Train, motion of a train along a straight track. Motion of a stone falling down freely. Motion of a stone falling down freely. Another example. 1D motion. Motion of a stone falling down freely. That is also straight line motion. Only one coordinate is going to change. Next, 2D motion. Two of the three coordinates. Two coordinates out of x, y and z. Two coordinates out of x, y and z are going to changes with time. Then that is called as the 2D motion. If two coordinates out of x, y and z are changing, then that is called as the 2D motion. Either it may be xy plane, or it may be yz plane, or it may be in zx plane. So any one of the plane it is going to change, it means changing its position. Then we can say it as the 2D motion. Example, motion of carom board coin. Motion of carom board coin. Motion of billiards ball. Motion of carom board coin. Motion of billiards ball. Boat moving in a lake is also an example for 2D motion. Boat moving in a lake. Boat moving in a lake is also an example for 2D motion. Next, after that, three-dimensional motion, if all the three coordinates x, y and z specifying the position of object changes, if all the three coordinates x, y and z specifying the position of object changes with time, and specifying the position of object changes with time, specifying the position of object changes with time, then that is called three-dimensional motion. All the three coordinates x, y and z changes with position and time, then that is called as the three-dimensional motion. Example, flying bird. Motion of a kite on a windy day. That is also an example for three-dimensional motion. Next, if you want to study the motion, you must require three things. One is origin, with respect to which you are studying. Note down. Important points to specify the position of object. Important points. Important points to specify position of objects. Those all three are required. One is origin. If you go through it, these are the three things which are required. One is origin. It is the fixed position about which the Position of object. It is the fixed position with respect to the position of object. It is a fixed point about which the position of object can be expressed. And also second thing, distance from the origin. Third one, direction of the with respect to origin. So these all things are required. For example, this is the position. This is the origin. And you are required to reach to this position. What are the three things which are required? One is origin you are required. And second thing, the distance of the point from the origin you are required. And third one, the direction also, in which direction it is existing. These all three things are required to reach to that position is concerned. So, one is origin, second thing is distance from the origin, third one, position. The direction of the position. Okay, these all three things are required to specify the position of the object. Okay? One is origin, second thing, distance from the origin of that position, third one, the direction of the position. So, you can reach to that position is concerned. So, there are another ways also there to reach to this position. What are those? Cartesian coordinates you are knowing. Suppose, what is its x coordinate and y coordinate? Then also you can reach to this position. That is called as the Cartesian coordinates. And the other is r comma theta. Those are called as the polar coordinates. There are two types of coordinates you are having. One is Cartesian coordinates, other is polar coordinates. If you are knowing x and y, then also you can reach to this position. X and y coordinate you are having, then you can reach to this position in 2 dimensions is concerned. And for the same thing, the distance from the origin and the direction or the angle with the x-axis or y-axis you are knowing, then you can reach to the same position. Those are called as the polar coordinates is concerned. And after that, you must know about the distance and displacement. And in the lower classes, 9th class also you have come to the same thing, distance and displacement. First of all, distance. Is there anyone who can define the distance? Anyone from the class? What is meant by distance?
The total path traveled by a body.
The actual length of the path taken by the object is called as the distance. Not all? The total. The actual length of the path taken by the object is called as the distance, and displacement is concerned. Anyone else?
The shortest distance from initial to final position.
Very good. The shortest distance between initial and final position and in the initial to final direction is called as the displacement. Note down? The actual length of the path taken by the distance is concerned. The actual length of the path taken by the object. The actual length of the path taken by the object is called as distance, and displacement is concerned. The shortest distance between initial and final position in the initial to final direction. The shortest distance between initial and final position in the initial to final direction. The shortest distance between initial and final positions in the initial to final direction is called as the displacement. Is called as displacement. If you take some examples, then you can get it understand. Suppose if the object is moving from starting position is O and it is reaching to Q. Okay? And here, suppose, and then once again it is coming back to P. Let this distance is 10 kilometers and this one is 5 kilometers. Okay? And the total is going to become 10 plus 5, 15 kilometers. Okay? So now, For example, if the body is traveling from O to Q and then coming back to P. It is traveling from O to Q and coming back to P. Then total actual length of the path taken by the object. So distance equals to OQ plus QP. That is OQ is 10 plus 5. How much it is? 15. 5 is going to become
20 kilometers.
20 kilometers. The same thing, suppose if you are going for displacement, the shortest distance between O and P, that is OP. OP equals to how much? 10 kilometers only. The shortest distance between O and P is 10 kilometers. So it is in the initial to final direction. O to P you have to take it.
So we have to write the directions as well.
So here, if you want to give the direction, initial is what?
O to P.
O and final position is P. So you are going to give the arrow mark from O to P. So initial position is O, final position is P. So you are going to writing it as OP bar. And similarly, another example, if a body is moving from diametrically from opposite end in a circular path, it is traveling. So you can imagine. So then, what is the distance and displacement? Let this radius is 7 meters. Suppose if the radius is, if I am saying it as 7 meters, then find the distance traveled and also
meters.
displacement.
22 meters will be the distance traveled and displacement will be 14.
Good.
40.
Distance equals to pi into r. 2 pi r by 2. Circumference is 2 pi r. Divide by 2 means pi into r. So pi is 22 by 7 into 7. So you are going to getting it as 22 meters will be the distance covered. And displacement is concerned. Here in this case, that is how much magnitude of displacement? 2 into r. Since this is also r and this is also r, 7 plus 7. So totally you are going to getting it as 14 meters. That is the 2r. Diameter is itself the displacement. So 2r. Displacement equals to 2r equals to how much you are going to getting it?
14 meters.
14 meters.
The direction
So
from A to B.
that is from A to B. Its direction is from
A
A to B. This will be the displacement is concerned. And suppose if the body is completing one circular path, just imagine it is starting from A and once again reaching to A. Then the actual length of it is how much?
44 meters.
So radius, if you are taking it as r only, that is 7 meters. Then distance covered in this case is concerned one complete rotation. One complete rotation. Distance is 22 by 7 into 7. So 44 meters. You are going to getting it as distance. And the same thing, suppose if you are going for displacement, it is going to become 0. The magnitude of displacement is concerned 0. Magnitude of it is, you are going to take it, that value is 0. So 0 meters. So distance may be never be 0 or negative. Distance displacement may be 0 also and also negative also. For example, if I am kicking a football from here and it is going to hitting the wall and coming back and coming to rest after 5 meters from me, this side, back side. Then forward direction, if you are taking it as positive, then backward direction is going to become negative. And that is displacement of it is going to become negative now. So that is why displacement may be 0 also, negative also, but distance always positive. Since it is the actual length of the path taken by the object. So now give the differences between distance and displacement. Take the table, one side distance, other side displacement. Anyone from the class? No.
Distance is a scalar quantity, whereas displacement is vector.
Very good, no doubt. Distance is a scalar quantity. And displacement is a vector quantity. It is angular direction. Next, anyone else? Definition is also one difference.
So distance can have only positive value, whereas displacement can have positive, negative and zero.
Zero. Not a distance always positive. And displacement may be positive, negative or zero is also possible. So positive, negative or zero. These all three values are possible for displacement is concerned. Next, definition is also one difference.
Yes.
Give there another difference. Anyone else? Anyone else?
Distance is the actual part, distance is the shortest part.
Good. Distance is the actual length of the path and actual length of the path taken by the object, and displacement is the shortest distance between initial and final position. Note down. This is definition is one difference. Definition of distance: the actual length of the path taken by the object. Actual length of path taken by the object. Here it is shortest distance between initial and final position in the initial to final direction. So these are all the differences between distance and displacement. When the distance and displacement both are equal, anyone from the class?
In a straight line.
In a straight line.
Here it is straight line only. Is it same?
When it goes in a straight line without changing any direction.
That's what you have to do. In a straight line without changing its direction if the object is moving, distance and displacement are equal. Note करके लिख दीजिएगा. Note down. The distance and displacement are equal if the object is not changing its direction of motion. If the object is moving in a straight line without changing its direction, the object is moving in straight line without changing its direction, then the distance and displacement are equal. Then the distance and displacement are equal. Then the distance and displacement are equal. Next, what is meant by speed?
Distance traveled per unit time equals to speed.
Speed is nothing but distance traveled per unit time. Distance traveled per unit time is called as the speed. The distance traveled per unit time is called as speed. SI unit of speed is meter per second. And dimensional formula is concerned m power 0
NT by
So the dimensional formula of it is concerned. Speed is represented by small v, and v equals to m power 0 L t power minus 1. M power 0 L t power minus 1. Next,
velocity.
is it a scalar or vector?
Scalar.
Scalar quantity. Next, velocity. The displacement per unit time is called as the velocity. Displacement divided by time interval. Displacement by time is called as velocity, and it is a vector quantity. Here also SI unit meter per second, and dimension formula is concerned. Generally we will represent with the arrow bar. V bar. That is displacement by time. Displacement by time. S bar by T. And it is a vector quantity. Okay.